Well, like previously, this also in this video, we're also going to talk about another special product, which is squaring binomials. Let me first tell you, remind you that, when we have like a squared, we say a squared because it is raised to the power of 2, and this means a times a. Okay, so the same form can be if we have like a plus b to the power of 2. Okay, this is the same as to say a plus b times a plus b. Okay, it's this kind of product. And then we can also expand this program and simplify the products as we usually do. So now we can do like a times a there, and then a times b, and then b times a, and then b times b. Now a times a makes a squared, a times b makes a b, b times a, which is ba, but I prefer to write ab. Multiplication is commutative. B times b makes b squared. Then, as you notice that we have like two like terms there, we can combine them, and this will be a squared plus 2ab plus b squared. Okay, so a similar case will be applied if it was a minus b squared like this. Okay, this will be a minus b times a minus b also, and then this will be like a times a times negative b times a, negative b times negative b, and then this will be like a times a makes a squared, a times negative b makes negative ab, negative b times a will be negative ba. I prefer to write negative ab, and then negative b times negative b makes positive b squared. Now we can simplify because we have like terms here, and then this would be a squared. Negative ab minus ab is not 0. This is negative, careful here, negative 2ab plus b squared. You notice that these answers are similar. Therefore, I want to give you a formula that we can use to solve this problem. So that says like a plus minus b, okay, to the power of 2. This is equal to a squared plus minus 2ab plus b squared. Okay, if it's a positive, if it's a plus b, we do a squared plus 2ab plus b squared. But if it's a negative, then we do a squared minus 2ab plus b squared. I'm going to write the formula over here. A plus minus b to the power of 2. This is equal to a squared plus minus 2ab plus b squared. Note that the sign changes only by the second term, okay, by the term 2ab. So if it was positive here it will be positive. If it was negative here, there is going to be still negative. Okay, now let's dive into the questions. Here we do have question 1. It is say that x plus 5 raised to the power of 2. So if I want to use this formula, I'm going to use the a plus b formula. So note that x here is like my a, and then 5 here is like my b. So this will be x squared, okay, a squared minus, no, not minus, but plus, because it's a positive there, plus 2 times x times 5, 2ab, okay, plus b squared, so 5 squared. So this is just equal to x squared plus 2 times x times 5, 2 times 5 makes 10, so 10x plus 25. Okay, it's shorter this way instead of as expanding as we normally do and then simplifying. Okay, question 2 is x minus 5 raised to the power of 2. Okay, this time we have a minus sign. Now we're going to apply the same formula. This will be x squared minus, now not plus, but minus 2 times x times 5 plus 5 to the power of 2. Note that the first and the last terms are positive always, okay, but the middle term changes depending if it was a plus here or a minus there. Now this will be just x squared minus 10x plus 5 squared. Simple, right? Now let's see question 3. We have like 2a plus 3 raised to the power of 2. Okay, this will be 2a. I'm going to just apply the formula. It's going to be 2a to the power of 2. So I'm going to write here 2a to the power of 2. I use bracket because I have more than I can't say terms, but we have like more than one thing here. There are two. We have 2 and we have a also. So I'm gonna say like that, and then over here I say it's a positive over here, so it will be positive there. This must be positive, okay? So I'm gonna say plus, okay, in the formula I had 2 there times. Now what a is what? What is a? A is 2a. Okay, so it's like 2a b, and then b squared there. So a is 2a, b is 3, plus the last term, b is also 3 raised to the power of 2 there. That's how it is. So a squared plus 2ab plus b squared. Now this can be simplified to, remember the power of 2 here will be for both 2 and a, not one of them, but both of them. Okay, so 2 to the power of 2 is 4, and then a to the power of 2 a squared, and then 2 times 2 times 3 is equal to 12, so that makes plus 12a plus 9. You notice that this is quicker, much quicker than timesing all the terms and then simplifying and combining like terms, you know, it's much quicker this way. Similarly, 2a minus 3 to the power of 2. So this will be the same thing as here, but the difference is like the sign will be negative. So I can just rewrite this, and then instead of putting plus, I put minus. So it's just 4a squared minus 12a plus 9. Okay, let's move on. Question 5. We have like a minus 4b raised to the power of 2. Okay, this will be a squared minus 2a is also a, b is 4b, okay, plus b squared, 4b raised to the power of 2. Okay, and then this will be a squared minus 8ab plus 16b squared. Okay, the power of 2 is on the 4 and also on the b. So 4 to the power of 2 is 16, b to the power of 2 is b squared. Now, question 6. Question 6, we have like negative a minus 3b to the power of 2. Now, don't let the negative signs here intimidate you, okay? The process will be the same as previously. Over here, I'll do, it's like negative a to the power of 2. So, negative a to the power of 2, okay? Now, okay, maybe I should do this way. Let me explain. You know, when you have like negatives like this, negative and negative here, it's like we're gonna write it this way. We can take negative as a common factor, okay? Negative, we can take negative outside the bracket. And then this will be a plus 3b. Okay, it's like negative a plus 3b. So negative a plus 3b raised to the power of 2. Okay, so it's when I say take negative as a common factor, I simply meant to say put the negative out the bracket. So it means like negative 1 as a common factor, okay? Or put the negative outside the bracket. Now the power of 2 here will cancel this negative sign because you remember if you have, even in the calculator, if you do -2 like this to the power of 2, the answer will be positive. Positive, which is the same thing as if we do 2 to the power of 2, okay? It's different than -2 to the power of 2. This is -4. But in this case, because we have this, the negative sign there, out there, this will be positive because the power is 2. So this is the same thing as a plus 3b to the power of 2. I don't know if it makes sense. First of all, we take the negative sign as a common outside the bracket. When we put the negative sign outside the bracket, this will become a plus 3b. Okay, a plus 3b raised to the power of 2. Then this can be a squared plus 2 times 3, 2 times a times 3b plus 3b squared. 3b raised to the power of 2. And then this will be a squared plus 6ab plus 9b squared. Okay. We can move on to question 7. We have -3a plus 5b squared, okay? -3a plus 5b squared. So now again, do not let the negative confuse you here. You know, one thing you can do, you can reverse the order. It doesn't matter within the bracket here. You can just, the same thing can be written as 5b minus 3a. And then to the power of 2. You can rewrite it that way. So far, we didn't solve the problem yet, but we wrote the problem in the way that's going to be easier for us to solve the problem. So now we switch 5a with -3a. If we switch 5b with -3a, so this will be like a squared. So it's like 5b raised to the power of 2. Okay. Now, because it's a minus here, we're gonna keep our negative sign there, minus 2a, okay, b, and then plus b squared. So this will be 2a, a is 5b now, and then b is 3a, okay, and then b is 3a. So remember that order, a minus b raised to the power of 2. Now this is the same thing as 5b to the power of 2. Remember, the power of 2 is for the 5 as well as for the b. So that makes 25b squared, okay, minus 2 times 5 times 3 makes 30, so -30 ab, and then plus 3a raised to the power of 2, that makes 9a squared. Okay. That was question 7. Now let's move on. Question 8, 3x minus 3y. Question 8, 3x minus 3y raised to the power of 2. Okay. Now the 3 is outside the bracket, so it has nothing to do with the power of 2. So this will be just 3 there, open bracket, and then x minus 3y, close brackets, no. You can just write like x squared, okay, because the formula I will apply it for what is in the brackets here, where this is like my a and that my b, and a minus b in the bracket raised to the power of 2. So it's going to be a squared minus 2 times x times 3y, okay, plus 3y squared. 3y raised to the power of 2. Okay, the bracket there. So situation like this is better to use square brackets, okay? because you have like a round bracket within the square bracket. So this will be like 3 open bracket x squared minus 6xy, okay, plus over here, remember 3 squared is not 6, but it's 3 times 3, which is 9, 9y squared. Then we can times by 3 there. Here is where we can do 3 times x squared, 3 times that, and 3 times that. And this will be 3x squared minus 18xy plus 27y squared. Okay. And then over here, now the difference is, you see, over here, the 3 was not in the brackets, has nothing to do with the power of 2. Reason why we kept it outside the bracket, we applied the formula for what is inside the bracket. Now in this case, question 9, we have 2 within the square bracket here, because outside the square bracket is a power of 2. Okay, I'm gonna write the question first. Question 9 is like 2 like this, n minus 3m or 4m was 4n. So m minus 4n like this to the power of 2. Now I was saying we have 2 which is within the square bracket here, and then the square bracket is raised to the power of 2. So the power of 2 is also for the 2 as well as for what is inside the round bracket. So this can be written as like 2 to the power of 2 m minus 4n to the power of 2. Okay, so here 2 squared is 4, and then we can apply the formula for what is within the round brackets. Okay, note that's a minus b there, so this will be open bracket there, m squared minus 2 times m times 4n plus 4n raised to the power of 2. So because of this, I will put also another square bracket here, call that round bracket. Now this will be 4, okay, round bracket, m squared minus 8mn plus 16n squared. Okay, no need to for square brackets, round brackets. And then we can times then 4 with base O, and then this will be 4m squared minus 32mn plus 64n squared. Okay, that was question 9. And now let's move on. The next question is question 10. Over here, we have x cubed minus 3y to the power of 6 or to the power of 2. I'm going to write the question there. Question 10. X cubed minus 3y raised to the power of 6 to the power of 2. Okay. Do not let the exponents within the bracket intimidate you. The method, the formula will remain the same. Okay. Now, remember all this x cubed is like a, and then 3y to the power of 6 is like b. Then this will be like remember the formula is a squared minus 2ab plus b squared. So a is going to be like x. Let me write it this way. Our formula is a squared minus 2ab plus b squared. Okay, so I'll substitute a is x cubed there, minus 2a is x cubed, b is 3y to the power of 6, and then 3y to the power of 6 there. Now this will be like the law of exponents says a raised to the power of m all to the power of n. This is just a to the power of m n. We times the product like that in this case. So over here we times the product, over there we times the product. not the product, I mean the exponent times exponent. So that makes x to the power of 6 minus, okay, 2, -2 times 3 makes -6, okay. Now note that this is x to the power of 3 and that y to the power of 6. X and y, the variables are not the same, so we cannot apply any formula here because they're not like terms. They will remain the way they are, okay. So this will be x to the power of 3, y to the power of 6, plus over here the power of 2 is for 3, which is 3 squared is not 6 but 9, because 3 squared means 3 times 3, that's 9. And then y to the power of 6 will become y to the power of 6 to the power of 2 will become y to the power of 12. So this is how when we solve the problem. Now question 11, question 11 says like 2a plus 3b to the power of 3 this time, okay. 2a plus 3b to the power of 3. Now I want you to notice that when we say a to the power of m, this means usually they say a to the power of n. This is like a times dot 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 times a n times, okay, n times, you times a n times. Now 2 to the power of a plus 3b is like 1 thing raised to the power of 3. This is the same as 2a, okay, plus 3b times 2a plus 3b, okay. Okay, times. This is like 2a plus 3b times 2a plus 3b times 2a plus 3b. Now, all this, you can say this can form 2a, we have like 2a plus 3b, and 2a plus 3b raised to the power of 2. Okay, so we can apply the formula there. Our formula will be then 2a to the power of 2. So I prefer to use square bracket here, because this is the form a plus b to the power of 2. So this is like remember the formula says a squared plus here 2a b, okay, and then c, and then plus c, plus b squared, okay. Now we can substitute. So a squared, a is 2a here, so 2a squared plus b plus 2 times a, so it's going to be like 2a again, and then b 3b, and then b squared is 3b squared there. Now this will be like 2a plus 3b, okay. That makes 8a squared plus 12ab plus 9b squared. Now we can times 2a with that, 2a with that, 2a with that, 3b with that, 3b with that, and then 3b with that. Now this will be 2a times 8a squared makes 16a squared. 2a times 12ab makes 24a squared b. 24a squared b. 2a times 9b squared will make 18a b squared. And now plus 3b times 8a squared will make plus 24 a squared b. And then 3b times 12ab will make 36ab squared. 3b times 9b squared makes 27b cubed. Now we can combine like terms again if there are any. No, over here I meant to say to the power 3, 16 a cubed. So is there any term that end with a cubed? When we see, no, we don't have any. Any terms that end with a squared b, we have one here. This is not the case because this is ab squared, so we cannot take that one. But this one, yes, we can. So this will be, we will have like 16 a cubed, 24 a squared b plus 24 a squared b makes 48 a squared b. Okay, because they're like terms, we can combine them. We can just add the scalar, the coefficients. Okay, and then the next we have like the term that ends with a squared. I mean ab squared. We have one there and another there. So over here also we will add the coefficients. 36 plus 18. This is equal to 54. That makes 54ab squared, and then plus 27b cubed. Okay. So the same way we did this question, I believe I will let you do question 12 because it's just the same thing but with a minus here. Okay. So now you're going to attempt to do question 12 yourself. Thank you. Please remember to like the video, subscribe, and share the link to many students. Thank you. Bye.